So in the panel today is Jean-Francois from IFREMER. We have Helen and we have Cristina from CNR. We have Nitan here from ISRO, and then we have, I hope we have Shakila online. Shakila, are you there?
Not yet.
Say that again, Kira.
Not yet.
Not yet. Okay, she might be joining later then. So let's start with some presentations and reflections and from some of the producers, and then afterwards I think we just leave the floor open for discussion and comments on what we should where we should evolve on this GDS and what's needed. Jean-Francois.
Yeah, so I will present you a brief status about the GDS and possible evolution that we may plan in the near future. So for those of you that have not seen yet what is the GDS that we have spoken about many times this week. So this is the document that provides GHRSST data product specifications. So basically describes the vocabulary, the format, and the content of the different GHRSST product levels, level 2, level 3, and level 4. And for each of these product level, it provides a list of recommended variables that should be put in the product, the attributes, the conventions that should be used for the flag and the quality information, the ancillary variables that should be added together with the SST, global attributes, and so on. So the first version of the GDS dates back to 2004. And then there were many discussions between the GHRSST 11 and 16 about reshaping this initial version. And the current release is now the version 2.1, which is accessible from the GHRSST website. So you have also the link to the Zenodo repository for this document. And the latest changes occurred in 2021, and they were mainly about fixing some typo and inconsistencies in the document, fixing examples and so on. So it's accessible, as I said, from the GHRSST website. It used to contain dynamic tables listing all the available GHRSST dataset, but it was never up to date. So we removed all these table, and this is replaced by the catalog for the product list and by a dynamic Excel tables for other codes like areas and the acronyms for the producers and so on. So why should you be using GHRSST GDS format? So as I said, it provides a common format for all SST products, and it has been adopted now by about 20 agencies. And we have more than 150 datasets following this format in the GHRSST framework, and there are many more every year. So at the beginning, it was really a pioneering, comprehensive set of rules for data producers. And it was really a multi-partner process and collaboration to update and to reach an agreement about how we should format this data and how every agency should follow it strictly. And in fact, it was so successful that it spawned multiple formats. So first, format, for instance, for radiometer data, for ice temperature that we aim at merging with SST, but also in other communities and other projects that took their inspiration from this initial specification document. So the benefit of having this common format is, of course, to provide interoperability between all the GHRSST datasets and services. There is a clear, unique vocabulary and associated definition. So we precisely define what is sea surface temperature, what are the different types of SST. And all this vocabulary and format specification is based on the heritage of the best SST experts. And as I said, about 20 plus years of discussion and agreement. So for a producer of SST data, it also saves time. There is no need to reinvent the wheel and to create a new format. It saves extra work compared to defining a proprietary format. It provides a built-in traceability metadata. The SST is shipped together with the relevant set of ancillary variables that allow the interpretation of the SST observation. For the users, it's much less hassle because everything is in the data in the same format. So especially for applications that need to merge multiple data streams like model assimilation and so on, this is really a time-saving thing. And as I said, so it makes easier the merging of multiple data sources or swapping from one data source when one mission ends and another starts. So really, it saves times for both producers and users, especially now that we have several tens of missions, SST missions available. So now it's time also to evolve a bit with this GDS that was not updated since the last 2 or 3 years. So from the feedback we got from users, we see that there are still some proof reading required because there are still some error and discrepancies reported on the examples and specification, or sometimes it may not be precise enough. So there is a little bit of cleaning to do. Also, we need a new and up-to-date format checker so that the producers that implement a dataset following this specification can easily check either through an online service or a Python script if they are fully compliant to the specification, because it's quite a heavy document. We discussed also this week about having the ice surface temperature included in the GDS. So there's been a work prepared between EUMETSAT, OSISAF, and CMEMS to provide some additional specification requirements that we need to merge as a new chapter within the GDS. And there are other things that we may consider also for the evolution of the format, which, for instance, like removing the packing of the data, so that to store the variables more in their scientific tab rather than in integer that needs to be unscaled, because this is a source of errors. It can introduce issues such as loss of precision, clipping, or saturated values. So many disadvantages that maybe are not required anymore since the volume of the data is not so much an issue. And anyway, even if we store the variable in their true scientific tips, there are ways to reduce the volume using different internal settings, such as the number of significant digits and so on. Also, we were requested by some agencies to relax the requirement on using the CO's vocabulary for the mission and instrument names. It was an issue, for instance, for geostationary or some operational mission, which have a different name when they are pre-operational and when they enter in operational phase. So we may allow both a version instead of just the operational name. Then there are specific issues to address about ultra high resolution data. So for instance, should we store the full latitude, longitude matrix? And also, since we are going to higher resolution, we should maybe also document better what the lat longs that we provide refer to exactly. Is it the center of the pixel and so on? What is the accuracy of this lat long information? So GDS was, as I said, was quite ahead of its time 10 years ago, because it was a really big achievement in terms of community agreement and precise format specification. But since that time, a lot of activity has been going on the format and storage improvement, in particular with the coming of cloud platforms. So we have also to evolve to adapt to that. So the volume limitation are not so important as they used to be. So that should also relax some constraints that we had on the format. NetCDF4 provides a notion of groups, so you can group different variables together, which can make the format a bit clearer. So this is a feature that we don't use actually currently, but that could be used in the next iteration of this format. It could be particularly useful, for instance, to separate multi-resolution variables who have different dimensions, or to clearly separate geophysical, geolocation, and ancillary information. It's also, I think, about providing a recommendation for cloud access to the NetCDF4 formatting. So providing, for instance, chunking rules, or using optimization, like Ed demonstrated in his talk earlier this week. And we heard also about new cloud optimized format like COG, NetCDF5 or Dhar. So we have to account for that without wasting this nice common set of vocabulary, variables, and so on. So probably we have to provide some guidelines in the GDS on how to convert, to apply the specifications that was defined for NetCDF to other types of format, so that we preserve exactly the same content with the same naming, and that we ensure a full traceability of the metadata when converting data from one format or to another. Yeah. And the last slide was, yes, has been discussed already this morning. So it was really also about taking advantage of the cloud access to provide a higher level data access services, to abstract, in fact, the fact that the data are in such or such format, or they are splitted in different files. So providing, for instance, access to data cubes that you can slice or extract time series and so on. And also, since the internal storage on the cloud is not so much important, if you are able to retrieve the data in the format that you want. So you could have the GRIS data stored in COG or in Dhar, but with some kind of web service accessible through a URL, still download a data file in the older NetCDF format and continue to use it in your application the same way that you did before. And there are also new conventions coming up for file search and catalogs of data, such as the stack that we may also look at to complement the currently open search access. So these are a few ideas for the improvement of and the evolution of GDS format. I think we have to move quite fast, especially related to this new cloud format coming up and with ultra high resolution SST, which may require some new format requirements. So probably in the next year we will try to call for the science team, organize some online meetings to propose evolutions and to involve the science team in this process. Thank you.
Thank you, Jean-Francois. Yeah, maybe we should also mention that, well, first just a comment then, that it's nice to see this, the evolutions going on, and maybe we should mention that, for instance, in terms of the future missions, the Copernicus imaging microwave radiometer, the SIMR, it's been adopted by ESA, both ESA and EUMETSAT. They will produce sea surface temperature products in GDS format. So they have sort of adopted the GDS in the future mission. So that's nice to see. So that's one comment. The other comment is that remember we have a mirror board online. I don't know if I forgot that in the introduction, but maybe Clara, if you can show that. We have a mirror board where we have put in some names on agencies and SST producers, where you are really encouraged to go in and provide feedback on the GDS. You can see what are the opportunities, what are the going down, what are the sort of the limitations and the needs and what needs to be evolved. So that's really our reference and where we collect all the information. So please go in there. It's a bit empty now, as I can see, or was before. Maybe it's filling up, I hope. But that's what we'll use after the meeting, also to guide the meetings and the evolution. Okay.